This is Indian Statistical Services question 1, year 2016, paper 1. Let us see what this question is saying. So it says that you have a jointly distributed function given to you. What is the function? The function is f of xy is equal to e to the power minus y. This is a joint distribution. And you have x between 0 and y between x and infinity, and it is 0 otherwise. And the question says, consider the following. So ideally, you have to tell which of the following are correct, which means you have to find ex, ey, and exy. These are the three things that you're supposed to find out. Let's see. In order to do this question, you must know what is the gamma function. So, what is it? It says that when I integrate from 0 to infinity, e to the power minus x, x to the power lambda minus 1 dx, this gives me gamma lambda, which is nothing but lambda minus 1 factorial. Now, how do I find the the marginal distribution? So in order to find the marginal distribution, we will always go ahead and integrate. So if I have to find the marginal distribution of y, I will integrate it over all values of x. If I have to find marginal distribution of x, I will integrate it over all values of y, right? So let's say I have to find the marginal distribution of x. What will be the marginal distribution of x? Because I am finding e of x. So the marginal distribution of x will be fx, which means I have to integrate over all values of y. And y is basically between x to infinity. So I'm going to integrate this over x to infinity. And when I integrate this function, I am going to go ahead and I'm going to get, so let's just try the let's just try the integration for a second here. So let's say that u is equal to minus y. So I know that du is equal to minus dy. So I know that du by dy is equal to minus 1. Just trying, if you, it's very simple, but if you want, you can use this method of substitution. So you will get e minus y dy as nothing as minus 1 u, which is nothing but minus 1 minus y. So it's very simple actually. Whenever you have an exponent, its integration is as it is into the differentiation of minus y, which is minus 1. That's the way to integrate. So you get minus e to the power minus y, and this goes from x to infinity. And when I go ahead and I put the value, this will be minus 1 by e to the power y from x to infinity. And this would be minus 1 by e to the power infinity minus e to the power x. And if you solve this, you will get minus 1 by infinity minus 1 by e to the power x. Anything by infinity is 0. So minus 0 minus 1 by e to the power x. And this is simply going to give you 1 upon e to the power x, which is nothing but e to the power minus x. Okay. So this is what we have got, e to the power minus x. Now, if we go ahead and we have to find the expected value of x, what is expected value of x going to be? It is saying that the expected value of x given to us is 1, of course. But how do we find the expected value of x? The expected value of x will be x fx dx, and x ranges from what to what? For us, x is going between 0 to infinity, isn't it? So I'm going to integrate x from 0 to infinity, and I'm going to get here as, because this is x into e to the power minus x, so x e to the power x minus x from 0 to infinity dx. And we know that if I have to go ahead and solve this, then we can go ahead and use this function here that I just explained you. If you know the gamma function, it works well. So let's say that I put my lambda equal to 2, right? What will I get? I will get integration from 0 to infinity e to the power minus x, x to the power lambda minus 1, which is 0 to infinity e to the power minus x, x to the power 2 minus 1, which is e to the power minus x, x to the power 1, 0 to infinity. Isn't it? Isn't this what I want? Isn't this the integration what I want? And I know that this is simply equal to lambda minus 1 factorial, which is 2 minus 1 factorial, which is 1 factorial, which is 1. Isn't it? So when I put lambda equal to 2 here, right, I'm just saying this is 2 minus 1 factorial is the answer, and 2 minus 1 factorial is 1 factorial, which is 1. So the integration of this from 0 to infinity, here also it is from 0 to infinity, so it is holding true. So the integration of this is simply 1 factorial, which is 1. So therefore the expected value of x is 1. This is a true statement. Okay. Now let's go ahead and let's try the next part. So we want to find out the expected value of y. That's the thing. Now let us try and find the expected value of y. To do that, I will begin by finding the marginal distribution of y. So what can I do? I can go ahead and integrate my function. My function is e to the power minus y. To find the marginal distribution of y, I will integrate over all possible values of x. So dx from 0 to infinity. When I go ahead and I do this, I will get e to the power minus y. And now I'm going to go ahead and understand this thing that now look here, see my x was between 0 to y and y was between 0 to infinity. So ideally, because the for x my range is between 0 to y, I'm actually going to go ahead and put here between 0 to y, right? And because I'm integrating over x and there is no x in the function, so I will take e to the power minus y as constant, and it's like saying that I'm integrating 1. And integration of 1 is simply x. So I'm integrating x from 0 to y, e to the power minus y. And this is going to be e to the power minus y minus 0. So this will be y e to the power minus y. So I have been able to get the marginal distribution of y. Now to find the expected value of y, this is going to be integration y into the marginal distribution of y dy over all values of y. Again, I'm going to make use of this fact, right? So y is also finally between 0 to infinity. So you are going to get here y into e to the power minus y dy 0 to infinity. So this is going to be e to the power minus y into y square from 0 to infinity dy. Now again, go back to the gamma function that I just taught you. And if I want to go ahead and I want to replicate this, because I have x square there, so the value of my lambda is going to be 3, isn't it? So when I'm going to put my lambda as 3, I will get 3 minus 1. So I will get 2 minus 1. I will get 3 minus 1, which is 2. So I am going to get e to the power minus x square between 0 to this. And this is nothing but lambda is 3 minus 1 factorial. So this is 2 factorial, which is 2. So ultimately, from here, using the gamma function, what will I get? I will get that the answer is 3 minus 1 factorial, which is 2 factorial, which is 2. So the expected value of y, that's going to be 2. Again, I think so that's what's given to us. So this is correct and this is also correct. Now let's find out e of xy. So in order to go ahead and do that, I'm going to go ahead and I'm going to, because I have to find expected value of xy, I have to use the joint distribution. So it will be xy into the joint distribution. So ideally, how do you do that? E of xy will be xy into f of xy. That's what is given to me as e to the power minus y dx dy and then double integrate. So in this case, because my, when I go ahead and I see this, I have this x between 0 to y, between x to infinity. So I have 0 to y and I have 0 to infinity. So when I will go ahead and solve this, I will first integrate it over all values of x. When I integrate it over all values of x, y into e to the power minus y will be constant. And this will be 0 to y over all values of x. And then I will integrate it over all values of y. Just focus on this aspect for now, okay? Only this. This is what you have to focus on. Okay. So when you go ahead and you do that, you will get y into e to the power minus y. Integration of x will be x square by 2. It will go from 0 to y, isn't it? And then you will integrate this entire thing over dy. So when you go ahead and you do this, you will get y square by 2 into y e to the power minus y from 0 to infinity dy. And when you do this, 1 by 2 will come out. You will get y cube e to the power minus y from 0 to infinity dy. But this is again your gamma function. And the value of lambda in this case is going to be 4. Only then you will get 3 here. So its answer is going to be 4 minus 1 factorial. And remember, you have half here. So 3 factorial by 2. So this is 3 into 2 by 2. So this is also your 3. So the expected value of xy will be 3. So if we go ahead and we see here, I'm getting expected value of xy as 2. So this is incorrect. Isn't it? So your correct answer is that 1 and 2 are correct. So this is your answer. This is how you can go ahead and solve this. The important part throughout here in this question was to go ahead and find the value of, to understand this gamma function. If you understand this well, if you understand how to solve it using this function, you can solve this entire question properly. Okay, thank you.